This is Linotype Model 31, a single distributor composing machine. Model 31 comes equipped with 1, 2, 3, or 4 magazines with a corresponding number of supporting frames. Standard equipment includes the one-turn shift for shifting magazines. It includes a gas-heated metal pot with positive microtherm temperature control. It also includes the 4-mold disc. The Model 32 linotype is similar to the 31, except for the addition of 1, 2, 3, or 4 auxiliary magazines. Matrices from the auxiliary magazines are released by means of a separate auxiliary keyboard. In the composing room, time is of vital importance. If deadlines are to be met and schedules cleared, high-speed production must be maintained day in and day out. Downtime and delays must be minimized. Blue Streak Master Models 31 and 32 have proved their capacity in the composing room. Both are outstanding production units. In the composition of straight matter, mockets, add guts, classified and commercial work, their efficiency is noteworthy. But let's start at the beginning and see how the linotype saves time and saves money. How its simplified, long-life construction makes linotype the best investment for your composing machine dollar. Note how the position of the magazines eliminates any danger of the operator bumping his head. Two inbuilt pivoting support arms hold the magazine without strain on the part of the operator. From this natural vertical position, the magazine is easily and safely lifted. Placement of a new magazine in the proper frame is accomplished in a matter of seconds. Back to keyboarding. But now a shift of magazines is required. It takes just 4 seconds and 3 easy turns to bring the number 1 magazine into operating position. Here we see the movement of the magazines from behind the linotype. The 2 drums in the lower part of the picture house the powerful spiral springs which counterbalance the magazine load. The one-turn shift is mechanically sound. There's nothing to get out of order. Keyboarding again. And now, for purposes of demonstration, the operator is going to attempt a shift while matrices are still being distributed. See? The hand lever won't release. Linotype's exclusive distributor screw guard prevents it. From the back of the machine, we see matrices still being distributed. There. The last one drops. Now the guard swings inward and the magazines are shifted. Again, shifting is prevented, this time by the matrix guard. Inspection reveals a matrix projecting from its magazine. The operator simply removes the obstruction. Now the magazines are easily shifted. This is what the operator sees when he's seated at the keyboard. Note how the optic aid front hides distracting moving parts. The no-glare finish stops light reflection. This means comfort for the eyes, comfort that minimizes fatigue. Linotype's keyboard has been precision engineered for a lifetime of dependable service. Its exceptionally sensitive key action has long been favored by operators. This, of course, is the famous swinging keyboard exclusively on the linotype. In a matter of seconds, working parts are laid open for adjustment or cleaning. Cam need inspection? Remove the cover, release the latches, open the bar. The cam lifts free with the fingers, simply and easily. Either front or back rubber roll shaft is removed by loosening but one screw without leaving the seat. The key bar assembly comes free as a single unit. This is accessibility that saves time, accessibility that encourages proper maintenance. Here we see the matrices and space bands feeding through the assembler and into the assembling elevator. Star wheel tension may be varied at will. It's just a case of moving the cover plate to one side and making the adjustment with a screwdriver. This close-up shows the assembler removed from the machine. Here's the assembling elevator again. The hinged long finger makes it easy for the operator to remove matrices and space bands. Even if pushed to one side, however, the matrices stay in their vertical position, held by Linotype's exclusive cam-actuated gate until the delivery slide is reached. Now watch the line stop. It's returned automatically, eliminating the need for manual setting with measure changes. Let's consider word spacing between large-size matrices. The M, N, and thin space buttons enable the operator to release a fixed space singly or in combination whenever the space band key is touched. Now we're coming to a change of measure. Setting the left-hand vice jaw is simplicity itself. The new measure calls for a new mold or a new liner. On Linotype's 34 mold disc, liners are changed without the necessity of removing molds or mold caps. The operator simply loosens 3 screws. He slips the liner from the mold. The new liner is in place in a matter of seconds. Now a word about safeties, of vital importance in the casting operation. First, the short line safety, which prevents the pot plunger from descending into the metal pot when a short line is accidentally sent through. Here it is in slow motion. To demonstrate its action, the operator deliberately puts through a short line, but it's never cast. Here's the reason. The safety stop indicated by the arrow stays in a closed position. It blocks the drop of the pot plunger. The line presses against and moves the right-hand vice jaw, actuating a series of levers which open the safety stop. There, the plunger drops into the metal pot, completing the cast. Should the operator wish to send through a line and not have it cast, he can conveniently hold the stop lever closed. Another protective device is the pot advance safety, which operates similarly to the short line safety. It blocks the pot plunger from descending when there is interference between the mouthpiece and the back of the mold. anything that prevents the pot from advancing its full distance. The pointer traces the leverage by which the full forward motion of the pot releases the stop lever. This permits the plunger to descend into the metal pot. Failure of the pot to reach its forward limit leaves the safety in its closed position and prevents the pot plunger from descending. The mold slide safety operates if a wrong mold or filling piece is in position, or if the mold disc is out of time. It prevents costly damage to matrices, molds, and machine parts. To demonstrate the protective action of this safety, the operator makes a machine change. He deliberately omits placing the proper filling piece in position. Now watch what happens when the mold slide safety, completely hidden from view, goes into action. There, the camshaft stops instantly, but no damage done. The operator simply backs up the machine, raises the elevator, and swings the offending filling piece out of position. Protective devices of this nature assume major importance in keeping production running smoothly. They protect the operator and your schedule. An important factor in the casting of quality slugs is the positive temperature control of type metal. To ensure a constant heat, Linotype provides the microtherm gas-heated metal pot, which closely regulates temperature both within the crucible and at the mouthpiece. The control operates with equal efficiency on natural, manufactured, or bottled gas. Many users prefer the microtherm electric pot. There are two controls. This one governs temperature within the pot itself. A second control regulates temperature at the mouthpiece. Rheostats are entirely eliminated. This cutaway model shows how two linotherm units in parallel are immersed directly in the type metal. The result is minimum heat loss and exceptional economy. Two additional linotherm units furnish heat to the mouth and throat. We come now to ejection of the slug from the mold. Linotype's universal ejector is easily set by means of a conveniently located handle. This scale shows the setting, from 4 to 30 M's by 2 M steps. The cutaway model shows how the ejector blades are held rigidly between heavy guide plates. There's no possibility of twisting or deflection while the slug is being ejected. In trimming, accuracy throughout the length of the slug is vital. Linotype's universal precision knife block has settings ranging from 5 to 45 points. It's noted for accuracy and for its simple, quick adjustment. Any one setting can be individually changed without affecting other settings. In shops requiring off-standard body sizes, this feature really comes into its own. The simple and positive three-bearing construction of the knife block helps to keep the knives in perfect alignment at all times. For parallel adjustment, micrometer screws are provided, assuring precise alignment of the right-hand knife with the left. Now for distribution. The handling of matrices is highly exacting, for the slightest misalignment at transfer points soon reflects in wear of matrix teeth. At the first transfer point, Linotype provides an adjustable plate for the positive location of the second elevator bar. Two screw bushings under these screws provide the means for precise adjustment. At the second transfer point, The elevator guide assures a perfect union between the elevator bar and the distributor box bar. Here it is in slow motion. Adjustment here is also made possible by two screw bushings. To facilitate quick passage of matrices from distributor bar to magazine, Linotype features a channel entrance with anchored partitions. And now, with several parts removed to enable the distributor screws to run while the channel entrance is left open, we watch the action of the exclusive spiral automatic. This device automatically stops and locks the distributor screws the instant any interference takes place. Even a slight pressure of the finger on the lower screw actuates the spiral automatic and instantly stops the mechanism. Once the obstruction has been cleared, it takes but a second to re-engage the spirals. Let's take a look at the Model 32 Linotype, identical with Model 31, except for the extra matrix capacity of the auxiliary magazines. The separate keyboard for the auxiliary side of the machine has the same exclusive swing-out feature that gives accessibility to the inner workings of the main keyboard. With a range from the smallest sizes to large display faces, Model 32 can take almost everything that comes along without tying up additional equipment. The centrally located unit control links the one-turn shift with either bank of magazines. Matrices from any one auxiliary magazine are composed with matrices from any one main magazine and automatically distributed. Master Model 32 is a Linotype of great versatility, a machine recognized for its low operating cost for both text and display composition. This demonstration of the Linotype would not be complete without a quick look at some of the additional production aids with which your new Linotype can be equipped at extra cost. This ingenious self-quanta automatically quads lines right or left or centers them without counting or filling in. Amazing gains in the production of certain types of work are credited to this simplified quadding device. Linotype's sturdy one-piece 6-mold disc reduces mold and liner changes to a considerable degree. It's an important time saver in shops where changes of type size and slug length are frequent. Thermoblow is an air cooling device that keeps molds from overheating. Since the air is not compressed, there is no moisture condensation. Thermoblow's patented construction concentrates the airstream on the mold itself. There is no cooling action on the mouthpiece, no draft to annoy the operator. The Moore Linosaw automatically cuts the slug to any measure from 4 to 30 picas by points. Slugs like these are ready for makeup. Linotype's quick opening knife block snaps open instantaneously to clear overhanging slugs in ejection. Where quantities of display slugs are being cast, this attachment saves valuable time. There's no occasion for resetting the knife block dial, no margin for error. The body size is held to exact degree. A flip and the knife block is closed. These attachments are plus factors of production. In some classifications of work, they may represent the difference between a profit and a loss. But now it's time to measure your own requirements. Why will Linotype best answer the needs of your plant? Because for over 60 years, Linotype has proved its capacity to cast quality slugs with standout economy. Because Linotype is flexible. Its ease of operation is exceptional. Safety is a prime consideration in Linotype engineering. protection for the operator and the machine. Linotype has all these advantages and more. You can expect extra years of service from your Linotype. From top to bottom, simple adjustments are provided to take up the wear that comes with thousands of hours of production. Linotype saves you money because it gives more production per dollar of capital investment and takes less time out for maintenance. For more profitable composition, make your choice Linotype.
These electronic devices are units that vary and add to the versatility of computer systems and exchanges of information between units. Corrections and the output of the computer itself are commonly made by paper tape punched in code. Borrowing a term from architecture, the computer men call the units modules. A dictionary gives these definitions: an interchangeable plug-in item containing components, an incremental block of storage or other building block for expanding the computer capacity. The GSA Special Purpose Computer Typesetting System, which the Monotype Corporation markets, fits these definitions. It offers building block variations to suit most monotype and monophoto machine setting, and line composition too. Whatever the configuration, it's all designed to anticipate tomorrow's needs today. The modular conception, then, must be ultra-modern. But is it? These are modules too. Alphabets of key buttons on a keyboard. Alphabets of type matrices in cases that go onto a casting or film setting machine. And all this began around 70 years ago. Machines like these, keyboard and caster, each operating independently, was a basic module in the new Monotype machine composing system. In computer language, the keyboard was an input and the caster an output module. And the link between them? Coded paper tape produced at the input machine to control the mechanism of the production unit and to identify the successive characters in the work being composed, to place them in correct order with correct spaces between the words and with lines automatically justified. So the pioneers of the Monotype Corporation forestalled the computer boffins by making use of the modular conception at the turn of the century. Let's develop our theme. The input device, the keyboard, translates copy into machine-acceptable terms, codes punched into paper tape. Keyboard operators today have greater resources beneath their hands than those of long ago, whose machines were simpler with fewer keys at their disposal. The mechanisms have been developed over the years, and the key banks have become larger and more sophisticated, but the principles of today's composition are no different from those which the pioneers established. The tape, when placed on the output device, the composition caster, controls the feeding of compressed air to selected pistons in two blocks. When pushed up by the air, the pistons govern the travel of the matrix case in two directions. So, because of the code control system, any one matrix can be brought precisely to the casting position over the mold at the right moment. The process is continuous, and when the machine is running at operational speed, the end product of this is this. The birth of these machines established a cardinal principle: separation of code punching and type production. Because of this, it is possible to vary the ratio of keyboards to casters according to the particular needs of each printer, as these sample installations show. Separation of functions also enables each operator to concentrate wholly on his particular job. Furthermore, it allows supervisors to arrange the work patterns of keyboard and caster operatives independently in the best interests of overall productivity. Improvements can be made to one item of the production unit independently of the other. For example, the display type attachment to the caster was introduced at a different time from the tabulating attachment to the keyboard. These trays contain just a selection of mechanical modules that have been devised through the years to improve the caster's versatility. We have always successfully built on the past for the present and the future. Even the newest film set has retained something of the family likeness. Now, why is all this versatility necessary? In many dictionaries, some pages require the use of more than 6 alphabets. To produce such works, and even more complex ones, at a sustained economic output, versatility of equipment is vital. It is vital, too, in order to maintain the high quality associated right from the beginning with the products of monotype machines, and also to ensure the ability of each unit to cope with the largest possible selection of typefaces and sizes. These needs were keenly appreciated by the inventor, Talbot Lanston. From his original matrix case containing 5 limited alphabets, we have progressed to 7 generous fonts and room for special signs. Keyboards have kept pace with matrix case demands. Their layouts have become steadily more logical. Instant character identification is assured. Our prime objective has always been the production of print of the finest quality. Clean cut, precisely spaced, elegantly proportioned. Type design, the creation of drawings and patterns, the production of steel punches, and finally of the character matrices, all are under constant inspection so as to maintain and improve quality. Until the end product of a type design is good enough to stand up to scrutiny under the microscope, it is not ready for production as a new series. Only the best will pass. Thanks to the modular nature of the keyboard and the ability to change modules, key banks, key bars, stop bar cases, and matrix case arrangements, our machines can produce high-quality composition in any type, style, size, or measure. They can do this not only in English and in all Latin-based languages, but they can also produce first-class composition in many exotic scripts. And now, if you're thinking such modules are all too familiar, how about these? We have some thoroughly modern modules too. These are from our latest machines, which include a computer input perforator, a paper tape conversion unit, a range of film setters, and an electronic perforator. Now we'll look at some of them and see how they demonstrate that the modular conception makes sound economic sense. Let's emphasize that economic sense bit. 84.5% of master printers employ fewer than 50 workers. But printers don't necessarily have to be big operators to compose all the varied jobs that may come their way. Their prime need is versatility, and the Monotype Corporation can help even those in a modest way of business to achieve it with up-to-the-minute modular equipment. Among our keyboards, casters and film setters, they will find items for a realistic outlay that will guarantee flexibility and high productivity. And although they may not be able to afford a general computer setup like this one, there's nothing to stop them buying time from a computer bureau. Today's composition caster with unit shift is very versatile indeed. Its case of 272 matrices has one more unit width row than earlier cases. Because extra movement is given to the matrix case, all rows but the first and last are dual purpose, so that now characters of different widths can be mixed in the same row, as this diagram shows. Key bars representing characters so placed have a unit shift lug built into them to cause the unit shift code to be punched into the tape along with a character code. With such improvements, hot metal composition will remain very much with us for the foreseeable future. But if the bulk of a printer's composition is designed for litho printing, then a monophoto film setter is an ideal machine, backed by years of accumulated know-how and experience. Two single, but by no means isolated examples show that the record of reliability is unrivaled.
This film is the result of a program presented by Mergenthaler Linotype Company to the American Newspaper Publishers Association. The presentation was designed to clear up the confusion which has been created by some of the proposals for exotic equipment that may someday be practical for newspaper production. Though directed to newspaper production problems, the basic theme applies to all typesetting requirements. We call it the tactics of tape setting. The theme of this program is tape. Tape that can be used with semi-automated or computer systems today. Tape that can train your personnel in the skills of tomorrow. For it is by tape that future equipment will be reached. This diagram represents the classic situation of men at machines. A completely manual preparation of news, advertising copy, and heads. This type of composing room is rapidly disappearing. More common is the tape preparation center, the stage popular with the industry today. Tape may be processed through a basic computer or fed directly to automatic machines. Manual machines supplement this production. Here is the stage some of the leaders in the industry have reached. This is the systems concept with an expanded tape preparation and data processing center. The computer system may even be used to process billing information. Here is the system of tomorrow, such as Mergenthaler's Linotron, tape preparation, electronic data processing, and cathode ray tube typesetting. And you cannot get from here to here or here in one giant step. One thing common to all these systems is tape preparation. Today's hardware must be tape-driven to be capable of evolving into future systems and must offer a high return on investment. Our concern then is the tactics of today, what we can do now which will integrate with a later and more elaborate program. The heart of any automated composition system is the tape preparation center. A basic perforator can produce unjustified tape at a rate 3 times that of a manual linotype. This tape can be processed through a computer, programmed to operate automatic linotypes, Linofilm Quick, or the Linofilm system. In addition, standard wire service tape can be utilized. The LinoQuick perforator is an ideal device for use with the auto-controlled electron when a computer is not utilized. It is the only standard production perforator capable of counting 4 different magazines. Setting measure is simpler than on any other keyboard, and the 45 pica line length indicated by this sliding scale, makes it ideal for linofilm quick tape preparation. Magazines in use are instantly displayed on the keyboard console. The operator always knows which font he's working with. The design concept of the electron linotype was based on the potential automation of all machine functions. Once the basic engineering design was firmly established, it made good sense to proceed to full automation of the electron mixer. The auto-controlled electron of today is a practical reality, which is being used effectively by a number of major newspapers throughout the United States. From tape control, the auto-controlled electron will change magazine, mold, knife block, and measure. Existing perforators of the type presently employed in most composing rooms may be used to produce the 6-level input tape. A single code configuration is used to call out the magazine, mold, knife block combination, and measure is selected by use of direct numeric codes, simplifying original keyboarding. Probably the most advantageous application of the auto-controlled electron mixer is classified advertising production. New ads can be produced and collated, including display lines and agate. Cut-off rules and blank slugs for spacing are produced in proper sequence. The result is galleys of classified and semi-classified ads with all lines in order, ready for proofing. Time-consuming slug collating and hand spacing are held to a minimum. Linofilm Quick was developed to meet the need for a machine to produce quality photo composition at relatively high speed and low cost. Operating from standard justified 6-level tape, the Quick can produce high-quality typographic images on film or photographic paper. The single area control panel permits simple machine monitoring. The monitor need only select a line length setting. Body size is pre-selected for each of the 4 grid positions, and film advance is then fully automatic. Point size range is from 5 through 18 points, in line lengths up to 45 picas. Controlled by wire service, locally prepared, or computer-generated tape, the Quick operates at a speed of 20 newspaper lines per minute. Under tape control are as many as 720 characters, the equivalent of 4 90-channel linotype fonts, including all of the typographic refinements generally not available in simple tape-operated equipment. Grids are easily changed in seconds. Each grid has 180 unique characters created from the master pattern plates used to make linotype matrices. Each character is identical to its hot metal counterpart. The width plugs, which determine the character width of each font, are external to the Quick and easily removed. Removal of exposed output is simple and requires a minimum of machine interruption. A new output cassette is readily installed, permitting a high percentage of efficiency in machine utilization. Linofilm Quick handles mixed composition with ease, heads with text, classified display, or sophisticated commercial typesetting. All point sizes base align, and it is possible to mix 8 type styles in up to 4 point sizes, even on a single line. Mergenthaler has developed an auxiliary tape reader to adapt the Linofilm Quick to composing rooms currently using Just-A-Writers. The Just-A-Writer tape reader is cabled directly into the Quick, and Just-A-Writer tape processing is straightforward. Experience has shown that substantial economies can be effected through the use of a linofilm system for the production of display advertising in the composing room. The linofilm keyboard with Linomix is in reality a special-purpose computer keyboard. It produces a tape containing all instructions required to perform every typographic function. It can call out any or all 1,584 characters available and space them in size and position through the linofilm photo unit. The photo unit produces properly spaced natural copy blocks of multiple sizes and styles, thereby greatly simplifying ad assembly. The linofilm system's proven speed and reliability have been further increased with the introduction of Mergenthaler's high-speed photo unit. Mechanical and electronic modifications and the addition of a function analyzer have resulted in an increase in speed of up to 60% over the earlier linofilm models. The high-speed photo unit has proven to be more than twice as fast as any competitive photo unit with comparable typographic flexibility. The function analyzer simplifies troubleshooting and maintenance by providing a visual reference to key functions as they occur. Every linofilm photo unit is capable of being made computer compatible through the addition of the computer tape reader. With this computer interface device online with the photo unit, the linofilm system is capable of producing the same variety of composition under computer control. Newspapers are now in a position to proceed into photo composition with the linofilm system, knowing that it can be brought under computer control when the computer system and the skills to operate it have been obtained. These are the tactics of tape setting, the utilization of today's skills and equipment to prepare for tomorrow's technology.
Now, in this age of jet speed, Mergenthaler presents the printing industry with a startling new concept. Electron. Here is fully automated typesetting, jet fast and all new from the base up. Automation starts here. Electron takes orders from perforated tape, delivering the goods here, 15 lines a minute. More slugs on the galley with less time and motion than ever before. That is the real measure of typesetting efficiency. Bright metal stacking on the galley. How does Electron do it? By continuous assembly through straight line delivery. No stop and go on Electron. The same number of operations that produce 12 lines a minute on other machines deliver 14 lines on Electron. A slight increase delivers 15. Continuous assembly, a wholly new concept, does away with the assembling elevator and moves matrices in a straight line to the first elevator, where they go to the casting position in a smooth, no-bounce action, made possible at all speeds by improved linkage. The mold disc is positioned accurately. It's free of vibration. Continuous assembly is backed up by an improved system for distributing mats, completing the typecasting cycle with a minimum of motion and effort. Yes, Electron is fast, but it never hurries. Electron's parts will have a long and healthy life. The path of Electron, straight as a gun barrel, a shorter path than ever before, reduces wear. Here's an old friend, just for comparison. This conventional machine demonstrates the path of mat travel on all line casting machines before Electron. It is assembling at the rate of 10 standard lines a minute. This is not in slow motion. Even while setting these wide column measures, it may be seen that the amount of time required for the rise and fall motions of the assembling elevator is a significant delay. The heart of Electron speed, one line travels to the elevator jaw while the next line is being assembled. Now, Electron is operating at 15 lines a minute, but seen in slow motion. In close now, we are watching the assembly of mats aided by a deft set of fingers. Two deliver the line, while a third dropped in to support assembly of the next line. The other two return and recycle as the line builds up. As the line fills up simultaneously with the release of each spaceband, a new lateral motion of the star wheel makes room for smooth seating of spacebands, thus eliminating interword delays. We've seen another all-new reason why, minute after minute and hour after hour, Electron delivers more lines with less effort than any other machine. A new rhythm for the composing room: continuous assembly. Continuous assembly through straight line delivery. But Electron is all new in detail as well as in principle. Take spacebands. When Electron returns them, they go directly to the spaceband box in one smooth motion. No more spaceband gathering. No more spaceband lever. One transfer lever delivers mats to the second elevator, and they head for home. The mats keep marching. 15 standard lines a minute. The payoff in silver and gold. Inside Electron, things are different too. Mechanical linkage in the justification system has been eliminated and replaced by a hydraulic system which gives constant justification driving force regardless of machine operating speed and reduces matrix and spaceband wear. Mergenthaler's exclusive assembler front. A simple lift-out motion frees the reed rack. Immediate accessibility. This dual-purpose motor drives the hydraulic system for magazine elevating and fanning, and the intermediate shaft for assembly and distribution. Note the short drop from the magazines to the assembler belt, further reducing mat travel and wear. Mats follow a near vertical angle, dropping to a new 5-pointed star wheel. Electron has practical new details, like this protective grille over the cam area, easily opened and closed for routine servicing. Subtle improvements are everywhere. Note this solid support given the pot pump mechanism, the heavy-duty construction of the second elevator mechanism. Clean, crisp styling by Henry Dreyfuss, right down to the base, in a new standard color, Electron Blue. But Electron's beauty is more than skin deep. Cam profiles have been redesigned to provide the smoothest possible operation at all rates of speed. A redesigned first elevator cam is new, smaller. A shorter, huskier follower lever and connecting linkage provide more positive motion in the first elevator slide, vibration-free. An improved line caster is still only as good as its mat distribution system, and Electron's is best. New second elevator linkage holds the elevator bar horizontal in travel, and mats are firmly held vertically without sway or vibration. The distributor shifter lever has been eliminated, and the shifter is electrically driven. The distributor clutch is all new, electromagnetic for fast, smooth stopping action. The font distinguisher is located at the entrance of the box, making simple the removal of wrong font mats. Electron's distributor system reduces mat wear to an absolute minimum at all speeds. These new improvements, combined with time-tested exclusive principles, permit safer mat distribution, the best ever. Electron's rear step, a removable cover over the electrical system. Here is Electron's main drive motor. Dual purpose, it drives the camshaft and the hydraulic pump for the justification system. A variable speed feature makes it possible to control the speed of the casting mechanism without affecting the hydraulic system. The electromagnetic clutch and brake eliminate the need for starting and stopping mechanisms, which on conventional machines require complex linkage. The hand wheel can be used to cycle the machine when necessary. Electron is pre-wired at the factory. Its power goes through this power control center. Low voltage is adjacent to high. Both feature plug-in components and individually fused circuits. Electron can handle up to 4 standard 90-channel magazines with push-button ease, elevating them hydraulically. Touch another button to fan them. Electron retains Linotype's built-in removal arms for easier handling. And equally effortless replacement. You have just been introduced to jet speed hot metal line casting. Full automation for effortless round-the-clock production. This completely new concept has been delivered to the printing industry by the only company that could, after years of research on the Linotype.
People change. Products change. Everything changes. And every change adds to the problem of communications. The rate of change is accelerating. Faster. 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 Stop! But you can't stop. You can't hold back the surge of change or the growth of information. It will continue in spite of you, and you're going to have to cope with it. Otherwise, the trouble is, how do you store all this information? Retrieve it and distribute it where it is needed in large enough quantities. The digital computer is a real help, but although it prints out data rapidly, the quality is that of a typewriter, and it's a line at a time. That's all. The information is there, but in a bulky form, and it's sometimes difficult to read. You can use conventional typesetting methods to improve the quality. But because conventional machines cannot keep up with the computer, the composing room is often bypassed, and computer printout is used for reproduction. That's why Linotron was built by Mergenthaler Linotype Company and CBS Laboratories. Linotron is a cathode ray tube phototypesetting system. It operates at computer speeds, but produces typography of traditional graphic arts quality. Linotron consists of 3 basic units. The first is a control unit, which provides interconnection and command control to drive the complete system. A single control panel contains all the operating and monitoring devices. An illuminated display indicates the frame or page in process. Settings for job number and for beginning and ending frame numbers inform both machine and operator of the progress of a job. Simple switches are used for starting, stopping, and selection of composing speed. Fault indicators warn the operator of such things as depletion of output film or the end of a tape. Status indicators show machine conditions through the entire sequence of operation. Three composing speeds are possible. Normal speed for high typographic quality. High speed with quality suitable for proofreading. Fast speed, up to 10,000 characters per second, to produce the equivalent of line printer quality. The second unit is the character generator, which converts the image of a character font into video signals, then transmits the selected characters in sequence to a third component of the system, the output or display unit. Here the characters are displayed on the face of a high-resolution cathode ray tube. This tube, in turn, projects the images onto photographic film or paper. This Linotron system was developed for the United States Government Printing Office. A second system for the United States Air Force produces line and halftone illustrations as well as text in full-page format. Let's look at the system in actual operation. It all starts with magnetic tape, Linotron's input. Magnetic tape is necessary because of the speed capability of Linotron. Touch the start button, and through control electronics, the tape is read. All the computer-processed information is here. Typeface selection, point size, page advance, and text, ready to be composed. Machine function and character selection codes are on the tape. All the necessary programming has been provided by Mergenthaler as part of its full system support. As the tape is read, the unique Linotron character generator selects typed characters from a photographic grid array. 256 characters are projected continuously on the cathode of the character generating tube. This projection is converted into an electron image from which characters are selected and corresponding television signals sent to the display tube. What you see here are characters actually being laid down on the face of the cathode ray tube. Linotron is not a line printer. It composes a page at a time, up to 8 by 10.5 inches in area, or in a turn page mode, 10.5 inches by any desired length. No time is lost moving through white space. In area composition, the page is composed without mechanical motion, and there are no delays between lines or between columns. Inaccuracies caused by film movement are eliminated. Since the unit of composition is an entire page, it is not necessary for all columns to be leaded uniformly, and less programming is required. Linotron's built-in oscilloscope monitors the composing process. Speed of composition is a true 1,000 characters per second. As a page is filled, the film is advanced by a transport system, and a new page is instantly begun. A page takes 5 or 6 seconds to complete. The Linotron's film cassette will hold a 500-foot reel of film up to 12 inches wide. At the production rate of 10 pages per minute, this is a 50-minute supply. The output cassette, holding 500 pages of text, is removed for processing. The final result? Photo composition produced in great volume at ultra-high speed with typographic fidelity maintained. From the Linotron grid to final output, there is no compromise with quality. Let's go back to the character generator and see why this is so. A precision-made font grid is the source of the array projected on the cathode of the character generating tube. It contains 3 complete alphabets. A full range of point sizes is available from a single grid with 0 access time, since size changes are produced electronically. Mixing of point sizes, even within a single line, is no problem. There is no need to convey width information on tape or through storage devices within the machine. The width of each character is stored on the grid, encoded in the form of a row of dots. A grid is easily inserted in Linotron's grid changer. 4 grids can be accommodated at any one time. A grid change, when called for, takes less than 1/2 second. Thus, over 1,000 characters are instantly accessible.
The quality of Linotron typography is a prime concern. Acting as consultant to Mergenthaler is Hermann Zopp, creator of Optima, Melior, Palatino, and many other distinguished typefaces. He is often called the greatest living type designer. Now, what of future applications of Linotron in printing and publishing? The systems now in existence and those presently being built are sophisticated and of great capacity. But development work is continuing. Linotron is expanding into a whole family of systems involving computer typesetting, tailored to individual needs in the fields of general printing, book publishing, newspapers, and computer printout. Technologically, this equipment is the result of several basic advances in the state of the art. The significant fact is, this system is here today, the right answer to the problem of the information explosion. In the future, as communications become more and more complex, there is one bright spot: Linotron.
The young men you're watching have something in common. Like so many other successful craftsmen in the printing industry, they learn the basics of their jobs at, yes, I'm sorry about that. I was going to say, at the Monotype school here. Some trained on composition casters. Others concentrated on film setters. Studied development techniques. And film makeup. Some explored photo lettering machines. Many learned how to operate a keyboard. All reported here. And were checked on here, on the battle plan. All ended up here for a few words of farewell from the principal. All received this detailed mark sheet. Most got this first-class certificate. Thanks to the efforts of instructors like these. Because of the efficiency of these men and their predecessors, we have received stacks of appreciative letters. We don't rest on these laurels. All the time we're trying to improve teaching efficiency. The latest all-out effort began at this desk. We got the latest modern aids like these to help in developing a new concept of teaching, group teaching. Why group teaching? To bring students along at a common pace, to rationalize training methods, to make the most economic use of staff. How's it all been done? By planning, research, and teamwork. This systems analyst produced data for the team to put into practice with the help of this and other teaching aids. The immediate point of the exercise, to instill into a class like this, within 2 weeks, the ability to attain speeds of around 3,000 keystrokes an hour with minimal errors. How do we ensure this positive progress? The scientist Pavlov, using dogs, proved that instinctive responses can be expected from repeated signals. The services and industry have used methods derived from Pavlov's experiments to aid training. So have we, to instill into students the instinct to strike each key with the correct finger, like this. Voice,
E, F, G,
light,
H, D,
bleep,
E,
keystroke.
F,
Voice,
G, H,
light,
H, I,
bleep,
J,
keystroke.
K, L,
Voice,
H, I,
light,
J, K, L, M,
bleep, keystroke.
N, K, L,
Next, character
M,
sequences for one hand, eye on the board and not on the keys, then
L,
sequences for both hands.
M, N, O, P, N, O, P, Q, R, S.
Later, with reflexes conditioned and typesetting drills thoroughly implanted, the students can paste themselves using headsets and a tape deck capable of providing a piece of copy at varying speeds. A student can change to a faster speed whenever he feels ready and can call for assistance if he needs it. The instructor can either advise the student over the microphone or go to his machine to check the output tape, for instance. But school timetables can't be all dexterity practice. Theory must be implanted too, and this is done in illustrated lectures. These take place in special rooms where the student's concentration can't be disturbed by noises from outside activities. We use modern aids such as this tape recorder, which is coupled with this slide projector. Illustration plays an important part in these lectures, which are planned to impart all the basic facts with a minimum of words. Each slide is automatically flashed on screen at the precise moment it's needed in the lecture. These pre-recorded lectures are carefully paced to suit average powers of comprehension. Students are given lecture notes too. At the end, the instructor is always prepared to answer questions. Now, after a fortnight's lectures and practice, they're beginning to cope with part 2 of the course, aided by morning briefings and use of the overhead projector. Now they're gaining confidence and are ready for work that will really extend them, make them think too. Now the Part 2 students have settled into a busy day-to-day pattern of early starts. Briefings from their instructors, starting up and preparing for the day's exercises. Getting down to work. Tea breaks. They need them. More lectures with the aid of the overhead projector. More exercises to complete each crowded day. Then come tests. Not that there haven't been tests all through. Every exercise has been cast, read and marked. But now they're facing really searching, long exercises to probe knowledge, to challenge speed and accuracy. No briefing to guide them now. First, a piece of typescript like this. Then a piece of jobbing work. A tough exercise in tabulation. And finally, some handwritten copy. These add up to about 6.5 hours of tests. Each student produces about 80,000 N's during the whole course. These are not specially designed exercises that tend to flatter students' performance, but are just the kind of copy they'll keyboard back at their works. Yes, it's hard work, not just during those tests, but all through the course. Worth it, though, as the principal will show from one student's record. Alan Beale, you'll meet him later, is an ex-soldier. He'd had no keyboard experience whatsoever before coming to the school. Here's his mark sheet. Each phase is marked. Each mark is given a weighting which decides its maximum value in the 100% total. A grand total of 80% and over earns, and we mean earns, the coveted first-class certificate. A full and confidential report goes to the employer. The student retains his mark sheet and the first-class certificate. That's really worth something to both student and employer. Always we carry on the drive for more efficient teaching methods and therefore better service to our customers. One aspect of service is the provision of aptitude tests. They're taken with the aid of this equipment before a man is committed to a keyboard course. This one is for reactions and manual dexterity. If a candidate can't measure up to these tests, especially in dexterity, it would be unwise of his employer to send him on the course. This test with a reading machine, which can be set to run at various speeds, checks the rate at which the student can absorb copy. Afterwards, his powers of comprehension and recall are checked by questions from this book. The group method is being gradually introduced to more courses. This is a lecture on caster theory. The humble blackboard is not despised. And in the machine room, the students study the same mechanism. So the group proceeds at a common pace. Teaching is rationalized. We can plan ahead more efficiently. More students each year can be accepted. To meet special demands, many individually slanted courses are made available, in non-Latin languages if required. Rona is from overseas, where many women operate keyboards. Like other foreign students who come to learn to work in their own languages, Rona speaks little English, but our instructors are equal to such difficulties. This chap is doing a special advanced course in the keyboarding of mathematics. This man is on a film setter mechanics course. When he's through, he'll be able to maintain all the machines at his works to give maximum performance. These students, Alan Beale among them, back after 3 months in industry, are on part 3 of the course, the final stage of their training, when we can judge their progress since initial instruction. At this moment, Alan is operating cleanly at upwards of 8,000 keystrokes an hour, because he's been building on correct foundations. Part 3 will help him to add to his steadily increasing productivity. His training has already proved to be a worthwhile investment. His employer says so in this letter. And what we've done for that employer and his operator, we can do for you and yours. Why not write for this brochure? Or better still, come and see for yourself.